we're going to solve an exponential growth problem. This problem, indicated here, says a bacteria culture initially contains 100 cells and grows at a rate proportional to its size. After an hour, the population has increased to 420. Part A here says to find an expression for the number of bacteria after T hours. Now, when the problem said that the bacteria culture grows at a rate proportional to its size, that means that we're going to be using the model y equals c e to the kt. The c here is the initial population, so from the wording we know that that is 100. The e to the kt part is what's known as the growth rate. In order to write an equation for the number of bacteria after T hours, that means that we're going to have to find a value for K. So we'll use the second part of the information, that after an hour the population has increased to 420. We know that 1 for T gives us 420 for Y. So we'll take our equation here and substitute in those values to find K. So Y would be 420 and C was 100, and T is 1. Now we solve for a value of K. We'll divide by the 100 here, giving us 4.2 equals e to the K. In order to get the K out of the exponent, we're going to take the logarithm of both sides. Notice that I'm using the natural log since it is the inverse of the e function. So now I've got the ln of 4.2 equals k ln of e, and since the ln of e is 1, we know that k is the ln of 4.2. Now we have the equation. We know what c is, we know what k is, so our equation for our bacteria culture is y equals 100 e to the ln of 4.2 times t. This satisfies A. Let's move to B. Find the number of bacteria after 3 hours. Since we have the equation y equals 100 e to the ln of 4.2t, we can easily plug in 3 for t. And then plug this into our calculator in order to solve for the value. Let's look at part C. Find the rate of growth after 3 hours. Now remember, e to the kt represented the rate of growth, and k was the ln of 4.2. So now you can plug in your 3 for t, and again plug in your calculator to find that decimal for the growth rate. Finally, when will the population reach 10,000? Part D. We know that this population of 10,000 is for Y. So we're going to put in 10,000 for Y, and we'll solve our equation for T. First, we'll divide by the 100, giving us 100 e to the ln of 4.2t. And then again, we'll have to take the logarithm of both sides. So the ln of 100 equals the ln of e to the ln of 4.2t. And remember that the ln of e is 1. That will go away nicely for us. Now we have the ln of 100 equals the ln of 4.2t, and we can divide both sides by ln of 4.2 to reach our answer. Be careful here, you cannot divide the 100 by 4.2. You must do the ln of 100 divided by the ln of 4.2 to get your answer.